Any questions for me at this time on level 5? Oh, only 7 questions. So you should be able to do a few of them already. All right, so let's get started. So as I said to you guys before, today is the beginning where you guys are going to need to be able to do everything forwards and backwards. Okay, so let's talk about multiplying. Polynomials. So with adding and subtracting, one of the things I talked about was that each base, each power is a fruit, right? So if I add 2 bananas and then put 3 more bananas, I have 5 bananas, meaning the base and the power still stays the same, right? We don't change it to a different fruit. However, multiplying, now we're going into splicing those different fruits together, right? So we can actually make a strawbanana, right? A strawberry mixed with a banana, which would be weird. I don't know if it would be like a strawberry skin with banana in the center or banana skin with strawberry in the middle. It'd be kind of weird, but we're splicing, okay? So with multiplying, what we tend to do is we're going to multiply the bases together, and we're going to multiply the numbers together. So for example, if we did negative 2x squared times 3x, right? So bases go together. So the x and x squared, they multiply together, while the coefficients multiply together. And how many x's would I have if I multiply x squared and x? Huh? We're going to have to use the exponent rules. Same base, different powers. What do we do with the powers when we multiply them? Right? So yes, now the exponent rules come into play. Right? So negative 2 times 3 is negative 6. Right? And then when I have x squared times x, same base, different powers, we add the powers. Are we okay with that? So that is called a monomial times a monomial, meaning a single term times a single term. Okay? Now, here, this is a monomial times a binomial. What's inside the parentheses is called a binomial, and terms are separated by addition subtraction signs. So to determine how many terms there are, it depends on how many addition subtraction signs there are. Since there's an addition sign in between these two terms, that is a binomial, while this term in front is a monomial. In this case, we have to do something called distribute. So we're going to have to distribute this through. So that means I'm going to take what's in front, multiply by the first term, plus multiply by the second term. Or better yet, let's do it this way. So notice that I did not put I'm not going to put a sign in between. Because what I'm going to do is I'm going to let the value of that coefficient determine the sign in front. If it's positive, addition. If it's negative, subtraction. Okay? So what is 4x times 5x? So what is it? 20x squared. Awesome. And then 4x times 7? 28x. Awesome. And that 28x is positive, so we're going to put plus. And there we go. Pretty simple? So no problem so far. Okay. So what if I had this? What is that called? A binomial. So what should we call this? A trinomial, because it's 3 terms. Now, guys, monomial, binomial, trinomial are the only ones that have special names. They're still considered polynomials, and anything larger than 3 terms are just going to be called polynomials. Even though these 3 are still called polynomials, they just have special names. Okay? All right. So what we would do here is going to be called a double distribute. So similarly, when I come in, if I had the exam, if I want to have the exam to pass out, then I would just pick up the exam and pass them out, right? But during the exam, you guys all know that I have the exam and I have scrap paper. So I'll take the exam, I'll pass those out, 2x. I grab the scrap paper and I pass those out. I distribute those, right? -8. So that's why it's called a double distribute. So what I would do is this right here. So I take the first one and I distribute it through the whole class. Then I take the second one and distribute that through the whole class as well. So now you guys see it looks very much like what I did up here in this example. And I have to do the same thing here. You guys are welcome, and some of you guys might need to do this, and it's okay if you guys do. And rewrite all of these out. Some of you guys can do this, but some of you guys might need something like this. Right? Some of you guys might need to do that. And it's okay to do that, guys. If it's going to help you see things better, do it. Now notice again, I didn't put any signs in between those, right? I'm going to let the value determine the sign in front. So let's go with the first one. What is 2x times 2x squared? 2x what? To the third. Awesome. What is 2x times -x? -2x squared, so I'm going to say minus 2x squared. What's 2x times -3? negative 6x, so I'm going to say minus 6x, was negative 8 times times x squared. So I'm going to say minus 8x squared. Negative 8 times negative x gives me a positive 8x, so I'm just going to say plus 8x. And negative 8 times negative 3 becomes positive, so I'm going to say plus 24. Does everybody see what I did? Are we okay with what I did? Okay. So, do I have like terms now? So now it's all addition, subtracting polynomials. So now we're going back to Monday's lessons, right? Do I have like terms? Yes, I do. This is like this. This is like this. And this doesn't have one, right? So notice how I stack them. So I got 2x to the third minus 10x squared plus 2x plus 24. Okay? Any questions there? Nothing? We're good? All right. So the question is, what would I do with this? I'll use x, why not? How many of you guys in high school learned how to FOIL? Nobody learned how to FOIL? 1, 2, okay. How about you guys at home? Anybody that learned how to FOIL in high school? Okay. I don't understand why they teach you guys FOIL. I have no idea why they teach you FOIL. Because FOIL, going backwards, doesn't do the so-called AC method, which is something you also learned. Back in my day, when I was in high school, there was no such thing as the AC method. Okay? So learning how to FOIL made sense because when I go backwards, we did something called trial and error. And that's all we had. So students either got it or not. And the teacher's solution of if you didn't get it was to give you more problems. Ed Smith, who sat next to me, always liked to talk. The problem is that he didn't get the math. I did. He didn't get it, so we just kept on getting more and more problems. Gave me more practice because I understood how to do it, but he still didn't, right? So in this case, you could FOIL if you want to. I'm going to tell you, if you like FOILing, to actually get it out of your head and actually double distribute as well. And I'll explain to you why you should double distribute rather than FOIL. Okay? So, and then the other way that you want to do it, you can do a multiplication table. I don't suggest it either. I'll show it to you, but I don't suggest it either. Okay? So, if I was to double distribute, here's what I would do. Right? I got that. Then I take the first term. I'm going to distribute through here. Take the second term. I'm going to distribute through here. Right? That is double distribute. Take the first term, distribute it. Take the second term, distribute. Then if I need to, I can always write these out. And then I'll have this. Is that true? Then I'll have like terms. Any questions on how I got this? So I still don't see some cameras on. I know the one camera that should be off. Everybody else should be on, and their face should be showing. And their name starts with a J. And your face, your whole face should be showing, not just your forehead. Not like you're a peeping Tom. Thank you for answering. Any questions here on what I did? I'm just looking at the chat right now, so thank you for someone jumping in there and answering that question. No questions? None? Do you guys want to learn the multiplication table way? It's up to you. It doesn't help. So remember why I said, hey, I'll do it this way. Remember how I said to you that everything that we do is going to end up going backwards. Is that right? Okay. So let me put it this way. So in the lessons after this lesson here, you're going to be given this problem right here. And from there, you're going to make that trinomial become a polynomial with 4 terms. And then you're going to make this happen. And then you'll get back to this as your answer. So notice that everything that I did here is everything I did here except backwards. Does that make sense? This is why I don't understand why they teach you FOIL, because then the next lesson becomes a lot harder. So this is what our goal is going to be. Everything that we learn how to go forwards, we got to learn how to go backwards. So we got to be able to take the answer and get back to the question. Any questions there? None. So you're ready to do one on your own. Awesome. Let's do some problems on your own then. Go for it. Let's see how well we do. You still want a FOIL. I will say this. If you decide to FOIL, that's certainly fine. I'm not going to do much about it. But I would tell you that the lessons after today will be a struggle. I promise you, a struggle. Well, you want to do it in your head because you're actually foiling. Is it 81x? Mm-hmm. You want to foil as well. Okay. You're good. Let me guess. For the ones that foiled, you got the same exact terms. But I'm going to tell you right now, the AC method is not going to get you those. It's not going to get you here. That's the reason why I say it. And you'll understand why soon enough. Because I know in your head you're like, but I got the same answer, so why can't we just foil? Now, I said on Monday, have I lied to you yet? So everything that I told you to do to be successful has been true. Why would I start lying to you now? Question is, can you go from there, the answer, back to the question? Now, this right here, what can you tell me? Does it look pretty special? Why do I call this special? Ooh. Dang, she threw out the word already. Yes, these are conjugates. Meaning the terms are exactly the same, right? They both have a 9x, 9x. They both have a 2 and a 2. But one's addition and one's subtraction. These are called conjugates. Okay? With conjugates, the oi always cancels out in FOIL. So with a conjugate, so whenever you have same terms, one's addition, one's subtraction, the center two terms always cancel out the oi in your FOIL. Because in FOIL, you get exactly the same thing. Same four terms. This is your first, this is your outer, this is your inner, this is your last. That's the oi that goes away. Okay? Okay, let's try another example, or another oil. what does the square mean? What is the squared attached to? The parentheses, which means we got to write the parentheses how many times? Twice. So we have to write the parentheses twice. If we write the parentheses twice, then we have two binomials. Make sense? And we have two binomials, that means I'm going to have to double distribute. What is the power attached to? The parentheses, which means we got to write the parentheses how many times? Twice. So let's write the parentheses twice first. No. So we just said that the power is attached to the parentheses, so that means we got to write this out twice. Which means what? I have to double distribute. Now, a lot of you guys think distributing the power. The problem with distributing the power, which is one of the exponent rules, that works for multiplication and division, but not addition and subtraction. Okay? So we do have to double distribute. Any questions? None? We're good? Okay. So I would strongly suggest to you guys, anytime you see that power, write it out twice. Because if it was multiplication, you'll see the distributing of the power anyways. Okay? So what I was talking about, if I was to go back, was this over here, right? So you guys were thinking about distributing the power, but this only works for multiplication and division, not addition and subtraction. So be careful with this rule. This is not the rule that applies to that problem. Okay? So, again, remember I said to you guys that x is just a number. Is that right? X is just a number. So, would you agree with me that that is also just a number? Because if I knew what x was, then I can square it, multiply by -2, I know what the actual number is. Agreed? This right here, that parentheses, is also just a number. If I knew what the value of x was, I can multiply by 5, add 7, and I'll have the number. Agreed? Okay. So that means with this right here, x is a number, y is a number, so that means that parenthesis is just a number. It's just a number. So why do I even bring that up? I bring it up because what if we had an example like this? Right? How many numbers do I have? 3 different numbers, aren't they? There are 3 numbers. Agreed? So if I have 3 numbers, how do you multiply 3 numbers? It's not a trick question. How do you multiply 3 numbers? If I said 2 times 3 times 4, do you multiply all 3 together and say, this is the answer? No. What would you do first? Multiply 2 of them, won't you? You go, okay, 2 times 3, that's 6. 6 times 4, that's 24. You could also do 2 times 4 equals 8. 8 times 3 equals 24. You can do 3 times 4 equals 12. 12 times 2 equals 24. Is that fair? Okay? So when you see this, same thing. Pick 2 parentheses to multiply together. Which 2 would you like to multiply together first? So you multiply those 2 first together. Okay. So and what do you notice about these 2? These 2 are called what? Conjugates. Awesome. I only have to play hangman with you guys. Then I take that product, and I go again. Why don't you guys go ahead and finish that? What are these called? Conjugates. Go for it. Finish it up. Hopefully you guys get this. Is that what you got? You'll get there. Mm-hmm. What's this times this? Write it down. Positive or negative? Mm-hmm. $65.61 negative. Combine like terms. Getting it? Okay. Any questions? 65, 61. Negative. Any questions at home? Yes? No? No? We're good? Okay. So no questions. We're good to go. So we've done adding polynomials, subtracting polynomials, multiplying polynomials. You would think that we're going to go into dividing. Make sense? We're not. That's for another day. So we're not doing dividing polynomials just yet. We're going to talk about now how to go backwards. So what does GCF stand for? Awesome. What does that mean? Greatest common factor. What does it mean? Okay, so she got the greatest part, the common part. Okay, so how about this? So what's the greatest common factor of 28 and 32? Okay, how about we do this? First, so the way the greatest common factor is supposed to work, okay, is this. So again, greatest, meaning the largest. Common, meaning the same for 28 and 32. Factor. What does factor mean? What are the factors of 28 and the factors of 32? Do we know how to find those factors? What are the factors of 28? How did you get those? Okay, very, very close. I like it. I like it. So essentially, you found them by saying what times what gives me 28, right? So let's make a table. 1 times 28. Does 2 go into 28? 2 times what? 14. Do we know if 3 goes into 28? Do we know how to figure out if 3 goes into 28? You plug it in the calculator, dude. Yes, that is one way you could do that. Any quick ways to look at it? So this trick works for 3 and 9. So if you add the digits, 28 is 2 and 8. If you add 2 and 8, it's 10, yes? If 10 was divisible by 3, then 28 would be divisible by 3. But since 10 is not divisible by 3, that means 28 is not divisible by 3. Just a quick look, okay? Awesome. So 3 does not, but 4 does. Does 5? How do we know if a number is divisible by 5? We can plug in the calculator, dude. What's the easier way? If it ends with 5 or 0. Okay? 6, if it's divisible by 2 and divisible by 3, then it's divisible by 6. It's divisible by 2, but not by 3, so therefore it's not divisible by 6. And then when we hit 7, we already have 7. So now we're done. We know where to stop. 32. Does 3 go into 32? No, because 3 plus 2 is 5. 5 is not divisible by 3, so therefore 32 is not divisible by 3. So those are my factors of those two numbers. The largest one that is in common is 4. So therefore we got it. So 4 is a GCF of 28 and 32. Okay? Here's the problem. If I have a very large number, or numbers that we're not used to, that table gets a lot larger. Do you guys agree? So I'm going to teach you a way. Now, remember what I said before. I'd rather give you one tool to do multiple things than multiple tools to do multiple things. Okay? So what I'm about to teach you is called prime factorization. You guys heard that word before, but you have no idea what the heck that means. It's prime factorization. And I use it for GCF, for LCD, lowest common denominator, and also for radicals, square root, cube root, all right? So those are, it works for all three of those. So I'm going to tell you how to do that instead. Do we know what the word prime factorization mean? Anybody remember that word? Just the factor tree. Do you guys remember the factor tree? Here, let's do it. So 28. If I was to tell you 28, what's the first pair of numbers that multiply together to give you 28 for you? 4 times 7. Okay. So I got 4 times 7. Is 4 a prime number? No. So what times what gives you 4? Is 7 a prime number? Yes. So we bring it down. So 2 times 2 times 7 is 28. Everybody agree? Let's do the same in the 32. If I said 32, what are the first two pair of numbers that you think of? Four and 8. Awesome. Is 4 a prime number? So that's 2 times 2. Is 8 a prime number? What's the first two numbers that come into your mind? 2 times 4? 2 is a prime, 2 is a prime, 2 is a prime, 4 is 2 times 2. So 2 times 2 times 2 times 2 times 2 is 32. But you should already know this. Why should you already know this? You carry it around with you every single day. Your phone, your laptops, your iPad. If I'm correct, whatever storage you have on those devices are all multiples of 2. Do you know why they're multiples of 2? What language does computers work on? Computers are all binary. Ones and zeros. Right? Yes and no's. How many choices are there? 2. That's the reason why your storage is also a power of 2. 32 gigs. 2 times 2 times 2 times 2 times 2. 64 gigs. 2 times 2 times 2 times 2 times 2 times 2. What's after that? 128. You guys heard 128 gigs. You guys heard 256 gigs. 512 gigs. And then it goes to a terabyte, right? But that's actually 1,024 gigs. You guys heard of the game 2048? Where you slide those tiles together, right? When you slide 2 and 2 together, you get 4. 4 and 4 together, it gets 8, right? But you can't slide a 2 and a 4 together, can you? But you can only slide 2 and 2 together, 4 and 4 together, 8 and 8 together, 16 and 16 together, 32 and 32 together because of that. We don't see a phone that is 62 gigs, 56 gigs, because those are not multiples of 2. So anytime you see 32, 64, 128, right, 256, 512, 1024, you got to think, is all powers of 2. How many 2s are there? That's the biggest question. Okay? All right. So if I look at these, I want to look at these two as 2 bins at a store. Okay? So when I was younger, when I was 8 years old, my parents started a restaurant, and my parents were so cheap. How cheap was she? My clothes came from the Champion store. Do you guys know the brand Champion? It's like the C with a white line, and then there's that part of the C is filled in. That used to be a store back in the day. That store sold Champion products, and they did a bunch of printing as well. Apparently, they trained people printing, apparently, because there was always a reject bin. Things that were printed upside down, the wrong side of the shirt. That's where my mom bought my clothes. So at some point in my life, I was number 5 on this basketball team. Well, I forgot what the basketball team was. I was number 5 one day, 4 another day, 2 another day, 9 another day. Those are the shirts that I wore to school. Okay? So let's say that I got invited to a baby shower. Not very good friends of mine, but they're only inviting me because they want stuff, right? They just want gifts. So since they invited me, I should go. They're not the best friends of mine, but they're good acquaintances, so I should be nice. So I go to the reject store, and I go, since she's having twins, I'm looking in these 2 bins. Okay? I'm looking at these 2 bins. So whatever is in the first bin, and I see in the second bin, I want to buy that because it's for twins. Does that make sense? So over here in this bin, there's a 2. So I'm looking over at this bin. Is there a 2? Yes. I want to buy that one. I look in this bin again. There's another 2. Is there another 2 over here? Yes. So I want to buy that one too. Over here, there's a 7. Is there a 7 on the other bin? Oh, no. Okay. Is there any other clothes that I can buy? Because there's another 2 over here, but is there another 2 over here? No. So that's all I can buy. Does that make sense? So what's in common is just the 2 and the 2 And if I multiply those, it gives me 4. Does that make sense? So I'm getting the same exact answer as before. Now you're sitting here going, but Chan, that took a lot longer. True. Very true. But do you think you're going to get faster with this? And here's the thing. Don't worry. You'll have a chance to make those factor tables as well. Okay? There will be a place and time for those. So we're okay here. No questions. Now again, I would tell you that this is worthwhile doing because again, there's 3 different places that I'm going to use this. And when we get to radicals, the factor table won't help you at all. But this will. So we're going to do this in the radicals for sure. In fact, if you go to my channel, you'll see me using that class right there, teaching about radicals, and actually doing a factor tree with it. Okay? And that's exactly what we would do. All right? So if you choose to do it, there it is. That's how we go about finding the GCF. All right? So let's talk about the difference between finding the GCF versus if they ask you to factor. Because in the directions, you're going to kind of get confused of, hey, what do they want from me? Because there's going to be questions that ask you what is the GCF. And there's going to be questions to ask you to factor. Okay? So you're going to need to know what's the difference between those two. So here it is. So let's do an example. Let's say I got x to the 5th, y to the 4th, z to the 4th, minus y squared, z to the 4th, plus xy squared, z squared. This is where you guys are going to hate me a little bit. You're going to really hate me a little bit. Maybe a lot bit, actually. So if I was to write these as factor trees, right, what's x to the 5th? Wouldn't it be x times x times x times x times x? Okay, let's write it down. 1, 2, 3, 4, 5. And then y to the 4th, 1, 2, 3, 4. And z, 1, 2, 3, 4. Minus 1, 2, 1, 2, 3, 4. Plus so we're now looking at 3 bins. What's in common in all 3 bins? Is there x's in common in all 3 bins? No. How many y's are in common in all 3 bins? 2. So in this bin there's 2. There's 2 here, and there's 2 here. How about z? 2 as well? Agreed? So ladies and gentlemen, so y squared z squared is what was in common. This, ladies and gentlemen, is called your GCF. So here's my question. If I was to buy those things that were in common, what is left in each of those bins? The first bin has what left? X to the fifth, y squared, x squared. The second bin has what left? Oh, sorry. Sorry. Is that right? Everybody agree? Are we okay? Yes? Do I understand where I got all those from? So again, what I highlighted is right here. Yes? I'm underlining everything that's left in this bin, and this bin, which is right here. Underline what's left in this bin, right here. And underline what's left in this bin, and that's right here. Are we okay there? Questions? Nothing? We're good? So, if you're only asked for GCF, this is GCF. That's all you need. Okay? So if it's asking for GCF, let me do this. Then that's all you need. Okay? However, if it's asking you a factor, then you need both of those. You need to get the GCF and what's left. That would be factoring. Questions there? No questions. We're good. We know exactly what I'm doing. People at home. No questions. Okay. So let's factor that. So this is the easiest possible problem ever. But it doesn't mean that everybody can do it, and it's okay. Any idea where I got all those numbers from? I'm waiting. Was I pretty quick at getting this right here? Would that be the prime factorization of 24? Did that take a long time? Because if you think about 24, that's 4 times 6. So 2 times 2 times 2 times 3 is 24. 18. Questions? Are we able to do this on our own? I know some of you guys will. No problem. If you can't, you should be asking questions like, where did you get that from? How do you go about doing that? Anybody at home have questions? Notice that with 18, I started with 2 different numbers, right? Before I used 2 and 9, and now I'm using 3 and 6. It doesn't matter what number you choose. It's when you get to the primes, it's all going to be the same. Jaden, you had a question?
No, that's going to be it. Thank you.
All right. Any other questions? Oh, of course I will. Let's do an oil because Chan needs to use the little boys' room. And that's apparently in the recording now. Great, Chan. Good job. There you guys go. Done? Break those numbers down. What's 8? Do some factor trees. Start somewhere, right? So do a factor tree for 8, do a factor tree for 72 and 32. What's in common and what's left? The more factor trees you do, I'm going to tell you right now that you're going to be faster and faster at it. And 72 and 32. Get it all done. Is 4 a prime number? You should already know the 32 because we already did it. How do we do? Where's our speed bumps? Where are we getting stuck? Where are we getting stuck? Where are we getting stuck? So what's inside the parentheses is called what's left. So if you notice that in each one of them, I circled what was left. That's not highlighted, right? So that's why you saw the first x squared, red, is because of 2 red circled x's. X times x is x squared, right? And then the second one, I got the 3 and the x circled. 3 times 3 is 9x. On the third one, in the green, you see the 2 and 2 circled. That gives you 4. Yes? For the GCF? Okay, so the question is, If you guys notice that the red, 2 times 2 times 2 and x times x, the blue, 2, 2, 2, xx, the green, 2, 2, 2, xx. Because those are the GCF, you only got to take it out once. You don't have to multiply them all together by any means. Correct. Correct. What other questions do we have? Are we okay? Yes? So where do we get stuck? Is it the willingness of making factor trees? Now, if you guys were STEM majors or engineer majors, I would expect that you guys already know that the GCF is 8. Right? And I don't care what the size of the number is, you should already know. As the number gets larger, guys, I don't do well with them either. And I was an engineer major. Okay? Now, in terms of making those factor trees, it does take time, doesn't it? But I would tell you this. The more I've done, the faster this has taken. Meaning, I know that 8 is 2 times 2 times 2. 72 is 8 times 9. 8 is 2 times 2 times 2. 9 is 3 times 3. 32, I already know that is 5 2s. Right? Now, are you concerned that the factor tree is going to take too much space on your paper? Okay. How about this? How about if I show you guys a vertical factor tree? So I asked the question, what goes into 72? Now, every time you ask this question, you got to use prime numbers. So let's say you're going to say 2 does. I'm going to say how many times? You're going to say 36 times. Very good. Is 36 prime? No. So what goes into 36? 2 does. Right. How many times? 18. You're right. Is 18 prime? No? Okay. What goes into 18? 2 does. How many times? 9. Is 9 prime? Nope. What goes into 9? 3. How many times? 3. Is 3 prime? Yes. Awesome. Guess what? 2 times 2 times 2 times 3 times 3 is 72. Does that take up a lot of space? No. So just do that. So what other concerns do you guys have? Nothing? You guys going to be factoring wizards? All right. All right, let me ask you guys this. What's my GCF? What's my GCF? What's in common in those two terms? It's not a trick question, guys. Trust me. Excellent. If I took A out, what would be left? You guys are doing it like I'm just trying to trick you guys. I'm not. Everybody agree with this? Awesome. Awesome. What's my GCF? What's left? We agree? Okay. What's my GCF? Still not a trick question. Okay. What's left? We agree with that? What's my GCF? What's left? Do you guys agree? So again, no trick questions here. Okay? There's a reason why I'm doing this is because it goes into the next section called what did I call this? Factoring. Okay. So this is step 2, but only if you had 4 terms. Okay? This is if you have 4 terms. Okay? Man, this thing is blowing up. So maybe I should take a look at what the heck's going on here. Because I think I got a feeling there's something I need to ask you guys. So anytime we see 4 terms, whoa. Whoa. Okay. So anytime we see 4 terms, and we're asked to factor, then we use a process called factor by grouping. Okay? There are going to be steps to this. Ready? Pay attention. Because if you don't pay attention, you're going to miss the first step. You guys ready? Ready? Step 1 is done. Anybody confused about the first step? What does that mean? It means that you look on the first group and say, what's my GCF? And what's left?
B plus 7.
Awesome. Then, let's factor this group. What's my GCF? Huh? And what would be left? Well, think about this. Right? So I can still do what I've been doing. Ready for step 3? Meaning now you got to look at the whole thing. What's in common?
B plus 7.
And what's left?
A plus 2.
Correct. How hard was that? Questions? No questions. So you're ready for oil. Good luck. Did we get stuck? So I'm going to guess that you guys had no problems with step 1. You guys were able to do this. Anybody struggle with step 1? No? Whew. I was concerned about that. You found the GCF of the first. Well, let's do this. So what I do know is this. I need this parentheses to look the same. Is that right? So what do I need to pull out of that second group so that that parentheses would look the same? Wouldn't it be a negative 1? So if I was to pull out a negative 1, well, I get the parentheses to be the same. Right? Because if you guys look, this is negative. I need it to be positive. This is positive. I need it to be negative. Now, you can always check your work. Because in order to make sure that this is correct, what I can do is distribute this back in. Does that equal to that? Yes. That times that. Does that equal to that? Yes. That times that. Is that equal to that? Yes. That times that. Is that equal to that? Yes. So that means my factors are correct. Now I can see, that what's in common here is 9y minus 2. And what I have left is the 2x minus 1. Okay? Now, with that being said, I'm going to put this asterisk right here. If the third term is a negative, pull out a negative from the second group. Right? If you notice, negative 9y is the third term. It's negative. So notice that we pulled out a negative from the second group. Now, here's my question to you guys. I need this to be honest, open. Is there a reason, well, I'm sure that some of you guys are using AI, like Chat, Claude, Gemini. There's other ones out there as well. And some of you guys are not. Is there a reason why we don't use AI? Why? It can make mistakes. What else? I love AI. Okay. Which one do you use?
I like chat.
Okay. Here's a good question. How do you know if you're getting good or bad information? Okay. So that would be curious, right? And I think that's why we want to either regenerate or ask a different AI the same question to see if it gives us the same answer. Because if it gives us two different answers, that means someone's wrong, right? Is there a reason why we don't use AI? People at home, you're welcome to unmute yourself and chime in. Why do we not use AI? What holds us back? There's a comment of, it's not always right. You're absolutely correct. What else? Sometimes it's better to do the work. Agreed. What else? Huh? Okay. We're not really learning anything and we use AI. People at home? I see you.
The formatting,
What do you mean by the formatting? Tell me more.
like if you were to put in an answer or a question to AI, like it would sometimes format like question wrong and do something completely different.
Okay. Okay. What else? Is there ever a question of like what to ask it? Yeah. Because I remember downloading chat and going, I don't know what to ask. I do believe that for the ones that are going out to the workforce after graduating, that you're going to find that the interview question is going to ask the question if you use AI. And I do believe that if you don't, you lose a job. I do believe, depending on how you use AI, if you do learn or not. Because it's like listening to the news. I shouldn't say this. I should say it this way. It's like listening to the news. There's truth to it. Many times, not the whole truth. But yet, we take it word for its word. Some of you guys might listen to CNN and believe its word, and some of you guys might listen to Fox News and listen to its word. Both of them give you truth, just not the whole truth. To me, I think the hardest thing to do is ask the right question. But here's the thing. Think about the questions that you ask your friends. Think about the questions you ask me. Think about the questions that you ask your parents, your mentors, your coaches. I believe that with AI, you have to treat it like it's one of them. Ask the question as if it was them. Difference is, like if you were to ask me, hey, how does the registration process work? I'd be like, I have no idea. I don't work at the registrars, right? I'm not an advisor. I wouldn't know, right? How often do we ask our friends those questions that chances are they don't know, but we still ask the question of if they know it or not? I think that chat is one of those things that you have to just kind of dive in there and just say, let's ask these questions. Like in my college algebra class, they did say, one of the things that they did was they did the review. The ones that they got wrong, They put it in the chat and say, give me another problem. Right? Can the problem be wrong? Maybe. Can the answer it gives you be wrong? Maybe. But what's the chances of the next problem it gives you being bad and the next answer it gives you being wrong? Right? So I've selected one of my classes to use something called Boodlebox. And Boodlebox essentially puts all the AIs together as one for us teachers to use and for us to try it with one of our classes. So essentially what I can do is say, chat, I want this answer, right? I got this question. It gives me an answer. I can say, Claude, what do you think about this answer? Is that true? I can go, Gemini, please take what chat just said and what Claude just said and give me a summary. The cool thing with chat, and I want to try this with my videos. So in chat, you can go into the other bots or other AIs. And so I took a YouTube video, the URL for the YouTube video, threw it in there, and it starts thinking, and then it spits out an outline of what that video is about. Right? An outline of it. So essentially, you guys could, well, I don't know if you guys can take my video or not. That's the live lectures, because it's now on YouTube. I wonder if you can take my video, the link of it, throw it in there, and say, okay, give me an outline. Now, I do believe that the outline is going to be more concept-based, and it's not going to give you like the problems it was done and stuff like that. I think it's going to give you like concepts, like steps and stuff like that is going to pop up. Does anybody feel like using AI is cheating? No? Okay. Some of us do. So cheating is a very fine line. Right? Sometimes you step over and you're like, I did? Dang it. Right? How many of you guys use Grammarly for your papers? Yeah? Guess what? If you use Grammarly too much, it's going to tell you that the whole paper was written by AI. Because guess what? AI is Grammarly. I'm sorry. Grammarly is AI. The other way around. Right? Now, day one, I encourage you guys to use AI. Right? Even for the what we know. So let's try it. Let's try it for this lab work. Use the AI of a choice. I don't care if it's Claude, ChatGPT, Gemini. Okay? So put the problem in and saying, hey, help me solve this. And then I want you to say, what are the 3 things, general information that I need to know to do this problem? So I can apply it to a similar problem. Okay? Have it spit it out. And then what I want you guys to do, so if you wrote just that down, that would be cheating. That's literally plagiarism. Agreed? So this is what you do. You take what it says, you open your notebook, you go, okay, where in my notes talked about this? What did he say in class about this? Now let's put Chan's words and their words together. Okay? Let's write that down. Let's see how Chan takes that. Try it. Let's see what happens. Okay? Because I do want you guys to start trying AI out. I do favor ChatGPT because it has a voice now. So I can literally, on my phone, I literally take it and I say, Chat, I need you to be my live translator right now. because my mom is at the doctor's office. Can you, when you hear Chinese, can you convert it to English? And when you hear English, can you convert it to Chinese? And she'll say, certainly, no problem. So I'll hand the phone to the doctor. The doctor will speak it, and I'll bring it over, cup it so that my mom can hear it, and it translates. Talks to her. She doesn't need to read anything. She just talks to her. So she's listening. And here's the cool part. After the doctor's visit is done, if she forgot something that she heard, it's already transcribed. So if I get out of the speaking part, it's in the chat itself, so I can just copy and paste it, send it to her. Now she can read it. And go, oh yeah, that's right, the doctor said this. Oh yeah, that's right, right. Some of you guys might have parents and grandparents that don't speak English very well. Maybe ChatGPT is a place for you guys to start with. And use a chat feature. Right? It's those type of things. Now, if you don't want it to be cheating, you can sit there, take a picture of a problem, and say, Chat, I just want you to walk me through this problem. Do not give me the answers. Ask me the appropriate questions to lead me to the right answer. Right? If you do that, it will lead you. Right? It will lead you. In fact, the founder of Khan Academy has been working with ChatGPT, and he actually has a video with his son talking about a triangle. You guys can actually find that one, and you hear Chat talking them through it. Hey, what is this side? What's this side? What's this side? Where's the angle? So if they're looking for sine, what is the actual answer, right? It actually talks them through it. I want you guys to try that with the lab work, and let me know how it comes out. Is that fair? Just try it. All right. Now, if you think of any other things that you feel like this is the reason why I'm not using it, let me know, because there's a large conversation right now talking about exactly that. Of like, I know that some of my students think it's cheating and don't know how to have it not be cheating. There are companies right now that literally has bought a subscription of ChatGPT for every single employee in the company. Why? Because the production is faster, and there's more coming out, so therefore it's actually giving them more money. Right? Instead of someone taking 20 hours to get something done, now it's taking them 5. Okay? So I want you guys to think about that as you're going and why it's important for you. And there's so much to learn. Yeah, there is, as long as you're willing to read. So for me, I've asked it about muscle growth after 50. Right? What do I need to know about muscle growth after 50? Like things that I might just ask Google, I'm just going to ask Chat instead. Right? Chat has just came out with deep research as well. So for research papers, it literally goes in and finds sources, and it will come up with like 50 sources, and then it will write pretty much like a research paper for you. But now again, you got to verify the resources, because it's really everything from online. So some might be true, some might be false. So you got to be careful with that. Okay? So other than that, ladies and gentlemen, please have a wonderful, blessed weekend. Please be safe. Love you guys. See you guys next week. Later.